So you need to calculate the probability that a tire is worn out before 32,000 miles. We are practicing the standardization process for normal distribution. So that's like this. First, this is the probability we are looking for. X smaller than 32,000, but X is non-standard normal distribution. And then you have to standardize X and also standardize 32,000. So manipulate them in the same way. And then X minus mu over sigma becomes a standard normal distribution Z, right? And, the other side, 32,000 is subtracted by 35,000 divided by 5,000, which will be minus 0.6, right? So 32,000 is 0.6 standard deviation below the mean. Its mileage is shorter than the average, right? So, and in the end, you just need to find probability smaller than minus 0.6 from the standard normal distribution, right? You may use Excel, and we know if you plug in minus 0.6 into the standard normal distribution formula, then you will get 27.425%. So use this is the answer. The probability that a tire is worn out before 32,000 miles is 27%. Okay? Okay, so so far we have finished one like full step. Like we learned that CDF, the cumulative distribution, is what we are going to use to calculate the probability for a continuous random variable. And then we learned how to calculate the probability for a standard normal distribution. And then finally, we learned how to make a non-standard normal distribution into a standard normal distribution. So combining these three, we we could solve this example. Still, there are different types of problems you need to practice. So I'm going to, in this video, we will do a lot of algebraic practices, exercises, because this is so important. As I said, all the probabilities from now on will be calculated in this way. And you have to master this technique so that you can calculate the probability later on. Okay. The next form of problem is to calculate the probability defined by greater than something. So we are interested in probability x greater than 30,000 miles, which is different from this, which is the opposite direction. So far, we considered probability smaller than something, but now we have probability greater than a number. And the difference is that, the cumulative probability is in this form, right? Z smaller than something, but this is the other direction. So you have to have one additional step to convert the cumulative probability into the probability with the opposite inequality. Let me show you. So in step 1, we have to standardize the random variable into a standard normal distribution, right? This process is now automatic. X will be replaced by Z after standardization. And then what you have to keep in mind is taking the same manipulation on the other side. 30,000 miles minus 35,000 divided by 5,000 equals minus 1. So after the standardization, this original probability you wanted to calculate becomes a different probability, expressed based on the standard normal distribution. Now, the problem is it is not a cumulative probability. Cumulative probability must be represented, expressed as z smaller than something, but this is z greater than something, greater than -1. So you have to have this additional step, right? Or you may use the symmetry of the normal distribution to convert the inequality to the other side. But whatever you use, you have to flip the inequality to this side, so that we have probability z smaller than something, smaller than -1, and then you can find this probability from Excel or a calculator. See, this is a part of value from the CDF. So you can calculate this value from the CDF of the standard normal distribution. So from Excel, you should be able to find probability smaller than -1 is 15.866%. And then the probability we wanted is probability greater than -1, which is 100% minus the other side probability. And in the end, we have 84.134%. This is the answer to this probability. Probability greater than 30,000 miles equals about 84%. Right? So the idea is the same. You just combine different ideas all together, like standardization and cumulative distribution, and like Excel, using the formula from Excel. So if you combine these three steps, then it shouldn't be that much difficult. But like I understand, it may look quite overwhelming, but you know, I believe you understand each step. Then you should be just careful to taking each steps. Then it won't be a big problem. Okay, now you need to do this exercise. So try this. What is the probability lasting more than 37,000 miles? It has the same structure, so if you need help, you may pick the previous slides and do it by yourself. Okay, if you have not finished yet, pause the video. So let's do this. Probability greater than 37,000. This is what we would like to calculate. And the first step is standardization, x into z. And then 37,000 subtracted by 35,000, and then divided by 5,000. And if you calculate this using a calculator, you will get 0.4. So we are calculating probability that standard normal distribution is greater than 0.4. But as you know, this inequality is not a desirable direction. So you hope to flip the direction of the inequality by taking this conversion. So instead of calculating probability greater than 0.4, we are going to calculate probability smaller than 0.4, and then take 1 minus that probability. That's what we are going to do. And you find 0.4, the CDF at 0.4 from Excel. Then you will get 65.542% for the probability smaller than 0.4. And then probability greater than 0.4 becomes the other 34.458%. Right? So this is just one set of steps. You can calculate a probability for non-standard normal distribution, right? Okay, and the next example we are going to study is a probability in between 2 points, right? This is the third form of probability we could calculate from a CDF. Now we are going to consider probability between 30,000 and 40,000, right? So how do we do that? Now, I will show you. So we have this, but as before, we need to standardize x, right? X is in the middle of the three terms. And when you standardize this, now you have to standardize all three terms. 30,000 must be standardized. 40,000 also should be standardized. And we have done this before, and you know how to do that. So 30,000 will be standardized to -1, but 40,000 will become +1. And of course, x becomes a standard normal distribution z. So a probability in between 2 points about x is a probability about z also in between 2 points, but those 2 points are transformed from the original 2 points, right? So they go through the same transformation, right? So far there is nothing new. We are using the same principles, same ideas. And then now, then how can we connect this probability on interval to CDF, probability smaller than something? And we learned probability between 2 points can be calculated by the difference between two cumulative probabilities. Probability smaller than the larger point minus probability smaller than the smaller point, right? So these 2 points, one goes here, the other side, -1 goes here. And then now you have to use Excel twice. So you have to first find probability smaller than 1, then use Excel once, and then you have to use Excel again to calculate probability smaller than -1. So if you find this, you are going to get 84, and if you find this, then you are going to get 15 something. So then subtract. That's how you calculate the final probability. So that is the probability that a tire endures between 30,000 and 40,000. Tire mileage is between 30,000 and 40,000 miles is 68 point something percent, right? So this is the probability we wanted to calculate. So as you saw, like from the CDF, we can calculate three types of probability. Probability smaller than, probability greater than, and probability in between 2 points. So and these three types of probabilities are just all possible forms of probability. So that's enough. That means the CDF can calculate any kind of probability you want. And now, okay, this is another exercise for you. So please do this, and I'm going to show you the answer in the following video. Okay, see you there.